Hello everyone. Today we're going to discuss the last topic of this chapter number 6, and today's topic is right angle triangles and Pythagoras property. So, what is this Pythagoras property? Before knowing it, let us understand the right angle triangle in details. Say for example, as you can see in the figure, ABC is a right angled triangle. So how did we come to know that it is a right angle triangle? Because according to the definition of a right angle triangle, a triangle in which any one of the angle is equal to 90 degree, so that triangle is called a right angle triangle. So here in this case, in triangle ABC, angle B is a right angle triangle, and as a result, this triangle ABC is a right angled triangle. Now in a right angle triangle, there are certain names given to the different sides of the triangle. So what are these names? So let us see. Now the side AC, as you can see, this side AC, it is called the hypotenuse. So hypotenuse is that side which is opposite to that right angle. So as you can see, the right angle is here, angle B, and the side which is just opposite to that right angle is called the hypotenuse. Here in this case, AC is our hypotenuse. Next, side BC is called the base. Now that is very clear and very obvious to you that the side which is at the bottom, that is the base. And the remaining side which gives the height is called the perpendicular height. So here AB is our perpendicular height. So these are the three sides of a right angle triangle. That is the hypotenuse, the base, and the perpendicular height. Now let us come to the Pythagoras property, which is also sometimes called Pythagoras theorem. So we are not going to the theorem here, which is obviously the same thing, but we are giving the name Pythagoras property. So let us see what is the Pythagoras property has to say. Now according to the Pythagoras property, we have hypotenuse square is equal to base square plus perpendicular height square. So the Pythagoras property states that this hypotenuse square of any right angle triangle, the hypotenuse square, or you can say the square of the hypotenuse, is always equal to the square of the base plus the square of the perpendicular height. This is what the Pythagoras property states. Now, in our case, our hypotenuse is AC square, base is BC square, and perpendicular height is AB square. So if you have to apply Pythagoras property into this triangle ABC, then this will be the equation. Clear? Now let us see some examples, then it will be more clear how can we apply this Pythagoras property into geometrical problems. So the first question states, determine whether the triangle whose length of sides are 3 cm, 4 cm, 5 cm is a right angle triangle. So we have to check whether this length of the sides, does it make such a triangle which is a right angle triangle. So I have to check it. So how to check it? It's quite simple. We can apply the Pythagoras property. But before applying the Pythagoras property, let us first find out the squares of these sides. So we know that 3 square is 9, 4 square is 16, and 5 square is 25. Now we have to make a combination of any of the two sides, or you can say we have to take the sum of any of the two sides and check is it equal to the third side or not, the square of the third side or not. So if you see here carefully, this 9 plus 16 will give you how much? 9 plus 16 is 25. So it satisfies the criteria that we have been trying to find out. So using the Pythagoras property, what we can say? We can say that 3 square plus 4 square is equal to 5 square. Clear? So since the square of the two sides of the triangle is equal to the square of the third side. So the Pythagoras property satisfies here. So as a result, we can say that the triangle that will be formed by these three given sides in the question will be a right angled triangle. Clear? Now let us move on to the next example. Now the next example says that ABC is a right angled triangle, right angled at C. The length of AC is given and the length of BC is given to us. We have to find out the length of the third side, that is AB. So let us see the diagram. So this is the diagram. Length of BC is given to us, length of AC is given to us. Now just we need to find out the length of the AB. Now if you see carefully here, AB is what? AB is the hypotenuse. So we can use the Pythagoras theorem here, or you can use the Pythagoras property. So using the Pythagoras property in triangle ABC, what can we write? We can write AB square is equal to BC square or AC square, whichever you want to write, plus BC square. So now some people might think that which one to write first, base square or perpendicular height square. Anyone you can write. You can interchange even their positions. If I consider this as the base and this as the perpendicular height, yes, sometimes the figure may be in a different alignment. Sometimes the figure may be this side and this side could be at the bottom. Then this will become the base and this will become the height. So even if you interchange them, that is not a big deal. But yes, the hypotenuse, the side which is opposite to the right angle, will be the hypotenuse. That is always true. But you can interchange the base and the perpendicular height. That will not cause any kind of problem. So here we have to now find out what is the length of the side AB. So we'll put down the value of AC, that is 5, we'll take the square of it, and BC is 12, we'll take the square of it. So we'll get 5 square is 25 and 12 square is 144. Now if we add them, we'll get 169. Now to remove this square term from AB, if we transpose this to the right hand side, this square term, then it will become the square root of this number. So what is the square root of 169? Now the square root of 169 is 13. 13 into 13 will give you 169. So we got our required length of AB. So the length of the side AB is 13 centimeter. Clear? So that brings us to the end of this chapter as well as to the end of this video. I hope you all have understood today's class. There are a lot of questions given in your textbook. You can try it out. This Pythagoras property is quite interesting. And this Pythagoras property can only be applied in the case of a right angle triangle. It will not hold true in the case of other kinds of triangles that we have learned. So Pythagoras property you can only use in the case of right angle triangle. Clear? So that's it then for today. Thank you and have a nice day.